Hello everybody, welcome to Chapter 9 where we're going to go much more in depth with strings. A lot of different material to cover, there's a lot of different sections in this chapter, so I'm not going to read off all of these lists. Just know that this list spans 2 different slides. So there's a lot of stuff to cover, so let's get started. The first thing that we need to be aware of is that strings are a collection data type. And so that means that you can think of it as kind of like a package. It's a container for lots of different stuff, and strings are a collection that is made up of individual characters. So for those of you that might have had some programming experience, this would be analogous to an array of characters in C++ or Java. Now, order certainly matters with a string, as string is not equal to whatever that word is, and a string with no characters is called an empty string, and so we would denote that by 2 quotation marks right next to each other. The cool thing about Python is it lets us do operations on collections, and so strings are no different. We can do different operations on a string. So for one, as you've seen already, we can concatenate. We can join 2 strings together, and we can use the plus operator to do that. So some examples would be we could combine a first name and a last name, although notice that there would be no space here. We could also combine a phone number with our hyphens in between them, and you could get the full phone number based on different parts of the phone number. We can also do repetition on strings. So a repetition is just a repeated sequence. So here we could say ra with an extra space times 3 would be equal to ra ra ra. Or Santa says ho with a space here. You can see multiplying that by 3. This string is now going to be ho ho ho. We can use the indexing operator to allow us access to get a certain character out of the string. So for example, if I had name as Corey and I printed the 0th character of name, you would return C. So notice the syntax here. We have the index, which is the number that we put inside the brackets, as well as this is the index operator. So the square brackets like this at the end of the variable is the indexing operator. And again, those coming from other languages would know this as just a way to access elements in an array. Now, one thing that's different with Python is that you can use negative indices to indicate a certain position from the end. So if I said -2, for example, that would give us E, because Y would be -1, E is -2, R would -3, -4, -5, and so on and so forth. Now it's kind of weird because if you're accessing it from the normal direction, we start with 0, so 0, 1, 2, 3, 4, but if we're accessing it from the end, it would be -1, 2, 3, 4, 5. So a little kind of peculiar there, but it's a very useful feature when we're getting into other collections. Now another thing to point out for those that are coming from other languages is that in Python, a character is just a string of length 1. In most other languages, a character is actually an integer value that's assigned based on its ASCII value. So Python, a single character is just a string of 1 digit. We have lots of different methods that we can use to operate on our strings. And remember that a method is a function that belongs to a particular class. So method and function are synonymous. You can't use a method unless you have an object of that class to invoke with it. These methods that we're going to use are extremely useful when we're going through parsing lots of text. And parsing just means kind of analyzing and using it, right? So let's take a look at some of the string methods that we have to work with. So now remember, these methods must be called with a string object. And that can either be a variable storing a string or an actual string within quotes. But we can call upper, which is going to return a version of the string in all uppercase, lower, capitalize. So these are all kind of similar in that they are going to modify the capitalization of it. Strip, we can remove leading and trailing white space. So if you want to make sure that you've got no spaces at the start or end of it, you could just call strip. You could call left strip and right strip, which is subsets of strip. We also have count, where we can count the number of occurrences. We can replace, so it will go through and replace anything we specify with something new. We can center it within a certain amount of spaces. We can justify it, and we can also find text within our string. Finally, we can also do right find. We can do index. We can say, where is this character at within the string, right? Or we can look from the end. And this list is not all inclusive, nor does it give every particular option of parameters that you can specify for that. If you want to know more, read the textbook and also go out and look at the documentation for the string class. Here you can see I went out to docs.python.org and I'm in version 3.8 and I'm looking at the built-in types, and this is all, if we go down to the string class, which scroll about a third of the way down, you'll see string methods. You can see we've got all of these different methods that are available to us, and it also gives you the list of parameters that you can use as well. So this is a great resource to find additional things that you can do with it. So everything that's in this list is in here, even with some examples on how to use different methods that are available. One method that I do want to spend some more time with is the .format method, which allows us to format a string in specific ways, and it's pretty powerful, but it can also get kind of confusing when you're first learning it. So here's the basic syntax, and I mean very basic syntax because it gets a lot more intricate. But here you can see that we have a placeholder. That's what these curly braces represent. And we have a string, and inside that string is the placeholder, and we call .format, and then we have a list of variables. These variables are going to get put into this placeholder in the order that they appear. So in this case right here, we're using the input function, which is going to return a string from the user, and then it's going to put it inside of this placeholder. So if we had two placeholders, it would look like this. It'd say, you know, we have this quote here that says my first name is blank and my last name is blank, and then we're calling .format and we're putting in Bob Ross. So remember that these go in an order, so Bob would go in here, Ross would go in here, and your output would look like this. As I said in the previous slide, that the format method allows us to get more intricate with the values that we're putting in. So it really is more than just filling in the blanks. So we can get detailed on how we want to shape our values that we're substituting in. So the first thing we can use is a conversion flag, which is really just like converting strings to ints and ints to strings. So here's an example of that. If we call exclamation S, it will convert the number that we pass in to a string. So that's just one example using the conversion flag. We also have the format specifier, which allows us to shape numbers in certain ways. We can change a integer to a hexadecimal or a binary number if we want by using this :x inside of our placeholder, or :b if we want to convert it to a binary number. We can also change floating point numbers to decimals or hexadecimal to decimals, or we can even do decimals with commas. So, you know, if your thousands, millions, and billions is grouped by a comma, we can do that. We can use fixed decimal. We can set precision where we want to specify a certain number of digits, right? Or we can specify a certain number of floating point digits. So say we want 2 decimal places. Well, in this case, we would use :.2f. And if our number had like 7 decimals, it would automatically round it to 2 decimals for us. And there's a lot more you can do with it. In fact, the format specifier is kind of like its own mini language. So you can see here that we have a format spec which tells us the order in which things need to go in when we are substituting them into our placeholders, right? So we have different fills that we can use. So we can say, hey, I want to fill you with certain characters. We can do certain alignments where we have left, right, centered, and justified. We can indicate whether or not we want to use signs. We can specify the width, as we've already talked about, which is our integer. We can use a comma or not. We can specify the precision, so how many floating point numbers do we want to include. And then we can also specify the type. So each one of these letters means something. Of course, I don't expect you to remember all of this off of the slides, so I highly encourage you to check out the documentation by going out to docs.python.org and then 3.8 or whatever the current version of Python is, in case you're watching this video in the future, and then library and strings. So let's go take a look at that real quick. So here we are at the documentation, and it lists all the methods that are available to the string class. And so if you scroll down again to about a third of the page, you'll see format string syntax. Okay? And I understand that reading this is probably not the easiest thing to do for a new student, but you should really try. Okay? Because learning to work through the documentation is going to be one of the biggest things that you can do to help your programming career or learning, right? But here you can see we have the format specification mini language. And so I know I showed you this chart in the slides, but this actually walks through what all of these things do. So it takes some time to go through and read it, which I'm not going to do here because you're adults, so you can read it yourself. But it talks about what all of the different letters mean and what the notation is, right? And then the best part of this is it gives you examples, right? So if you come down here, you can see that we have certain examples of accessing arguments by position. So here you can see that we can specify a number which corresponds to the order in the variable list here in the format method, right? So if we call 210, then you can see that we are going to list these in reverse order. So there's all kinds of crazy stuff that you can do. You can put names inside of your placeholders and then access those values in here. So here you can see that this is saving this coordinate as latitude. Well, that's going to go into the placeholder that's labeled as latitude. And so there's all kinds of different options here. I'm not going to read through all of them, but I highly recommend that you go through and you get a good working knowledge of how to do some basic conversions. Use the format specifier in simple ways. You don't have to get crazy, but like here, right here, using comma as a thousand separator. You can see that they're using the colon comma as I talked about, and they're putting in this number. When it gets printed, you can see that it has inserted the commas automatically for you. Here you can see the precision with the percent. So here it's giving you 2 decimals of precision, right? So there's tons of stuff that you can do. Go out here, look at the documentation, learn to read the documentation. If you have questions, I'm always here to help answer those questions. Length is a built-in function. It's not necessarily a string function, but it works on any items in a collection. We're talking about it with strings because you're going to use it a lot with strings. And when you're using length with strings, it's going to return the length of the string, which includes white space. The other thing that you have to remember with length is that it returns the total length of the string, not just the number of the last position. So remember, we zero index things. We start with 0 and go 0, 1, 2, 3, 4. So Corey, for example, length would be 5, whereas if I access the fourth element of the array, or excuse me, the collection, it's going to be a valid position. So this right here would return Y. Trying to access the 5th position would not, because it would be after the Y, which is not valid, right? Because C would be 0, O is 1, R is 2, so on and so forth. The slice operator is another little bit of Python magic, and it works just like index, except for it returns a range. And it has several different forms that it can take. So we can have from a start index to an end index, which is not inclusive. We also can use the colon and a number to indicate start at the beginning and go all the way up to some number, not inclusive. And we can also go from some number to the end of the string. So this is good ways to return substrings. So here you can see a couple different examples. Hello world, we can give it :5 and it'll return just hello, right? Because 0, 1, 2, 3, 4. Remember, it's not inclusive with the last digit. If we gave it 7, it would return just world because it's going to start at the 7th position. So 0, 1, 2, 3, 4, 5, 6, 7. So starting at W. We can also give it a range. So starting at 7 is going to give us W, and then 8, and then we're stopping at 9, which would be R, but remember it's not inclusive, so it's 7 up to but not including 9, which will just return whoa. We can also compare strings using the comparison operator. For example, name is equal to Corey. If I then check to see if name is equal to Corey, it's going to print out the same. We can also check for lexicographical ordering based on using the less than or greater than operator, right? So does a word come before or after the word in a dictionary? So here's an example of that. Is car less than tree? And that's going to return true. Is Mike less than Bob? False. Now, you know, Bob might take offense to that, but that's okay. We like Bob. We know he's awesome. Now, we have to understand that lexicographical, and sometimes I say lexicographical because I'm lazy, but it's lexicographical. I don't like the word. Anyway, lexicographical ordering is based on Unicode point values. So these are, each letter in every language is given a certain value based on a Unicode standard. And we can use the ORD function to determine a character's ordinal value. This is an original value, it's its ordinal value. And ordinal is just a fancy way of saying that how things are related to something else. Is it less than or greater than some other thing? Now, as far as the Unicode characters go, it's an extension of the ASCII character set, but as we've found out that, you know, ASCII is not enough to service the world, and so we've had to expand on the ASCII character set to make coding more universal and not just, you know, focused on English. You can go out to several different websites, but here is just the Wikipedia entry for Unicode characters. And so here we can see that there's some early characters which are subsets of other commands, which we're not going to get into. But if you scroll down, you can see that here is the list of US typical English language characters. Okay, and here's the Unicode point values. Let's look at the column heading. So here you can see the code, right? Here's the number of the Unicode. So this is what is determined by whether a letter comes before or after within Python. All right, and you can see this is a very long list that covers most of the Latin characters, right? And then we've even got some symbols, Greek symbols, so on and so forth. So this is not all inclusive. There is thousands and thousands of different characters. If you think about all the Chinese and Japanese, Korean languages and all their special characters, Cyrillic and so on and so forth. So there's lots of different characters. This is just a summarized list, as indicated right here. Not technically possible to list all these characters, blah, blah, blah. Okay, so that's Unicode. It's just an extension of ASCII. In other programming languages, you're going to see ASCII come up quite a bit because that's what the char data types are. They're ASCII values. But with Python, we use Unicode because it's more international. Now, I know this video has been pretty light on examples so far, so let's go ahead and do an example. Let's write a compare function. And it's going to take two strings as parameters. It's going to return a negative value if the first word comes before the second. It's going to return 0 if the two words are the same. And it's going to return a positive value if the second word comes before the first. We also want to make sure that we test this out, so we're going to include 3 test cases using our trusty test module. So let's go ahead and build this. So let's jump over to Visual Studio Code, and we'll go ahead and shrink this a little bit. We're just keeping it there as a reminder of what we're doing. We're writing a function that takes 2 strings as parameters and returns a value based on their ordering. And we also need to write test cases. So the first thing I'm going to do is we're going to import our test library, right? So we're going to import test, making sure that the actual module, the test.py file, is in our current working directory. Whoops. Nope, we don't want test. Sometimes autocomplete can do terrible things to you. Oh, terrible. There we go. Let's just click down here. All right, so now we've got test imported. Now we want to define our function. So we're going to start off with the keyword def for define, and we're just going to call it compare string, right? Compare string. And we said that we needed to pass in 2 words, right? So we're going to just call it word 1, and we're going to call it word 2. Now, if we want to be fancy with it, we can do some type hinting here, where we just say, hey, word 1 is a string, and word 2 is a string, okay? And that's just to make it easier for people that are using our code to know what these parameters are supposed to be. But it is not necessary. You don't have to do this, so we can leave it off if we want. The next thing we want to do is we want to write a doc string, so that way our users know what to do. And we're going to say, well, this is going to compare, it compares 2 strings based on lexicographical ordering, right? And we've got word 1, which is first string to compare, and we've got word 2, which is second string to compare. And I recommend that you follow along and type this out as I'm typing it, just to help give you that extra practice, right? And we're going to say returns negative if word 1 is less than word 2, positive if word 1 is greater than word 2, right? And 0 if same. All right, and we end our doc string. All right, so now notice that we're keeping our alignment with the doc string that we've already written. We simply say, now we get into the bulk of our function here. And so knowing what we know, we could say, well, if word 1 is less than word 2, we want to return -1. That's easy enough. Elif, right? Else if word 1 is greater than word 2, we want to return a positive value. And then otherwise, we just want to return 0. Again, this is, you have an option. You could say, well, I want to make this explicit and say else return 0, or we could just leave it as the default case no matter what and not have the else there at all, right? Okay, that's it. That's the function. But now we want to test it. So we're going to exit out of the function body. So notice that we're back here aligned with the def and import keyword, because alignment is everything in Python. Test, we're going to call test equal, right? And we are going to call the compare string function with 2 strings, right? We're going to say, we're going to pass in, let's just do hello, and we'll pass in world. Whoops. Now we know from our brains that hello becomes before world, right? So we want to say this should return a -1, right? So that's just testing it. Then we're going to test the opposite, test equal, compare string, and we're going to pass in world and hello. And we know that this should return a positive number because our logic and what we said it should do, right? So now we need to do one more test, and we need to test that they are equal. So test equal, compare string, and where you want to test, we can just say, you know what, let's say Bob. I like Bob. So these 2 things should return the same, so these should return 0. Notice how, whoops, not inside that one. So the ordering of your parentheses matters, folks. So notice here that we've got this function right here as our actual value, and this is right here is our expected value. Okay. Now if we go ahead and run this, we should see our results, right? So let's go ahead and run it. Gonna hit the play button, and here you can see it ran it and all 3 tests pass. And you might be asking yourself, this seems really stupid. We know that this is going to do what we say it did because we coded this right there. The point of unit tests is to just double check your sanity and your logic, but more than that, it is you usually write your test to an expected response because it's going to tie into other parts of a software system. So for some reason, our software system says that when we're comparing 2 strings, they should return these particular values. At a later point, you might change the logic of your code up here, but the net result needs to stay the same because it's already embedded in your program in a 100 different places. 100? Yeah, that's sure. So the point of these unit tests is to make sure that if you change something up here, you don't break the rest of your code, right? So when you run your tests, no matter what you change, if your tests pass, you can be confident that you're not going to break other sections of your code, right? So what would happen if I accidentally said, well, maybe I just fat fingered something and this became -2 for some reason, and then you ran your tests. Now you can see that our tests fail, right? Because it didn't pass what we expected it to do, and that would be a sign that you messed something up, and you got to go like, okay, well, where did this fail? Now, this test code is very rudimentary and it doesn't give you any additional information on what it failed, what the test was, where it was at. There's test frameworks that are much more robust that will tell you these things, right? But this is just a simple test just to get you in the habit of writing test cases. So we know that we just changed that. We're like, oh, whoops, I must have messed that up. And so you go back up here and you fix your code and then you rerun it, confident that whatever changes you made didn't break the entire system, okay? So you have to look beyond the trivial toy problems that we're working with here and think about it in a larger context of working with software that has hundreds of thousands of lines of code and thousands of different modules and so on and so forth. Okay, nothing in programming is really this easy when you're working on real problems out in the wild. Okay? Strings are immutable. What does that mean? Well, immutable means that you can't change it. So in Python, when we change a string, we're actually creating a new one. So this is an example of something that you cannot do. We can't have a variable called greeting and we give it a string. We can't change an individual character in a position. We can't change this to Jello world. It would generate an error because strings are immutable. If we want to change a string programmatically, we can take the slice operator and create a new one like this. So here you can see we are taking our greeting and we're saying new greeting is equal to J plus greeting from position 1 on, right? We could also, instead of using a new variable here, we could also just use the greeting over again if we didn't need to create or didn't need to retain the original string, and this would still work, okay? Because it's not going to assign it until everything over here is done. So that's just something to keep in mind. In some other languages like C, you can change things in place because they're arrays and they're immutable, but in Python they are not, so you have to create a new one. As I mentioned previously, strings are a collection, and that means we can process them using loops. And when we process something using a loop, we call it traversing. So for example, in this list of names, when we traverse through this list, every time we go through the loop, it's going to grab the next name in the list to substitute for a name. Now, when we're working with strings, since strings are a collection, it's a collection of letters. So a character in the string go spot go is going to be each letter of this string. So here we are processing each word in the list of words. Here we are processing each letter in the string, which includes spaces. So this is going to print G, and then O, and then space, and then S, and then so on and so forth. We can also traverse over a collection by using an index. In this example, we have the string, Happy Thursday, and so we're using an index I for the range of length of the string. And so each time we are going to access the ith element of the string, so it's going to start at 0, and then 1, then 2, then 3, and so on and so forth. So this will print out Happy Thursday vertically, but we're going to access each letter one at a time. So using our newfound powers of string manipulation, let's write a program that can prompt a user for a word and check to see if it's a palindrome. Remember, a palindrome is a word that is spelled the same way forwards and backwards. Race car, mom, dad, etc. So what we need to do is we need to make sure that we are getting our user input. We're going to create a Boolean function to check word, and then we're going to output the appropriate response using the format string. And of course we want to run it inside of a main function. So let's go ahead and write a program that does all this. Okay, so here we are, and we said the first thing we want to do is to make sure that we run it in a main method. So we're just going to start off with define main, right? And we can add a doc string if we want, colon, main part of program. That's not necessary because it's self-evident, but we'll put it in there anyway. And then finally we also need to make sure that we are including the standard if name is main, blah, blah, blah. So that's there. So now we're guaranteed to execute the main part of our program, right? All right, so what else do we have to do? We want to define a method called a Boolean function, that is going to check to see if a word is a palindrome or not. So we're going to call it, remember, Boolean functions start off with is, because it's like, hey, is this something? Palindrome, right? And then we're going to pass in a word. And of course, we want to include a doc string, right? Checks to see if word is a palindrome. Okay. Word. The word to check. Returns true if word is palindrome. False otherwise. So there we go, some clear documentation on what our function does and how to use it, right? All right, so this is going to be pretty simple. So all we have to do is we need to obviously check to see if the first element in the word is the same as the last element in the word, and then we want to move in from the ends, right? So we're going to check the first and the last characters, make sure they're the same. We're going to check the second character and the second to last character, make sure that they're the same, right? So let's do this using a for loop, because we know how many times we need to check something. So we're going to say for I in range, because we're going to go through a list of numbers, right? In the range of the length of the word, right? Now here is something that you need to think about. Do we need to go through the whole word, or do we just need to go through the half of the word? Because once we get halfway, we've already checked the other half. So we don't need to go through the whole thing, because that would really be checking it twice. So we're just going to go ahead and divide the length by 2 using integer division, because we don't want a decimal number, right? All right, so if our word is 7 characters, it's going to go through 3 of the characters, right? If it's 8 characters, it's going to go through 4. And that's another thing to think about with a palindrome. If you're using a word with an odd number of characters, once you check the first half of the even characters, right? So in the case of a 7-letter character, once you check the first 3, the 4th character is the middle. It doesn't matter what it is, it's going to be good. So we can check n-1 characters for odd numbers. And so by dividing by an integer, we guarantee that we're only going to get a certain number of characters, an even or excuse me, an integer value for the appropriate number of characters. So you'll see what I mean here. So we want to check to see if the word that we've passed in at position I, right? So in this case, we're starting at the first character, so I is going to be 0. If it's not equal to the word at the position of minus I, right? So in this case, we don't have an actual I because, well, I is 0, and we know we can't check the negative value. And remember I talked about earlier when you're checking it from the end, it's going to be off by 1. So we want to say, well, we want to check the word from the I plus 1, right? So in this case, if we're checking the 0 character, then this is going to be the -1 character from the back. All right? So then we can go ahead. If that is not the case, if they are not the same, we are going to return false. And that's really all we have to check. And if we get through all of the letters and it returns and it's never returns, then we are confident that we can return true because we have met the criteria for being a palindrome, right? So that's our palindrome function. Now we want to go ahead and, you know what, let's write a test for this. Let's make sure it actually works. So we're going to go ahead and import test. We're going to import our test module, and we're going to come down here and we're going to write a test, right? So we're going to say test equal, right? And we're going to pass in the expected or the actual result. So we're going to say is palindrome, and we're going to pass in wow, right? We'll just use all lowercase. Right? Now we're going to say our expected value should be true. It should return a palindrome. Let's also do a negative test case because we want to check our equivalency cases. Let's check, we'll say dog, and that should return false. So let's go ahead and run this and see what happens. And you can see that it tested good. Both tests pass. So before we write anything else, we've tested our function and we know it works as intended. We could say, well, let's check to see one other thing. What happens if we capitalize something? Wow, right? Well, that's still a palindrome, so it should return true. It failed. Well, now we can make our program more robust because we just added another test case to this, and we say, how could we make sure that we check for capitalization? Well, really, we don't care about capitalization. So what we could do is we could simply say word is equal to word dot lowercase. So here's that string function again that we were using. And now we're just going to go ahead and make everything lowercase so we don't have to worry about capitalization. And we can run it again. And it says has no attribute lowercase. So I messed something up. Well, so I could say, okay, well, what are my options? Well, I could load up my Python interpreter. And since strings are a built-in class, now Python didn't load up here because I had been making some changes to my Python installations, and so I don't have my Python in my environment variables anymore. So one of the things I have to do is I have to paste in the actual location to my python.exe, and that gets me my Python. So now I can say, well, help with my string class, right? So I want to look to see what other methods there are, because I don't really remember. What is it? Was it 2 lowercase? Was it lowercase? What was it, right? So is lower, okay, that's not what I want, so I can keep going through. Lower returns a copy of the string to lowercase. Oh, okay, so I screwed that up. All right, so I can exit out of this, right? And now I can just go up here and just say, oh, there we go. So now we've got dot lower. So now we can go ahead and run it, and we can see that we've got another issue, invalid syntax. Well, let me figure out what that was. In this particular case, it's because I'm still in my Python interpreter. So it's trying to execute this line of code, which is not a line of code. So I forgot to quit. All right, now I'm out of the Python interpreter. Now I can run it. And now you can see that we've passed all of our unit tests. So that's pretty good. We know our palindrome is working pretty good. Let's test it. Let's add one more test case. We know that it's working with an odd number. So let's go ahead and test equal is palindrome with a 4-letter word or a even letter word. Let's go ahead and use non. I love non. Non is delicious. So this should return true. And if you're not familiar with non, it's just a flatbread from Southwest Asia. So it's really good. Anyway, so that passes. So we're confident that our algorithm is working for solving if something is a palindrome. So now we just need to add to the main part of the program what we actually wanted to do, which was we need the user to input whether or not something, we want to ask the user to enter a word, and then we're going to check it, right? So let's go ahead and store that, right? So let's add a comment here, get user input, and we're going to say word to check is equal to input There we go. So now we've got our user input, right? Then we want to say, we want to check to see if the palindrome, if the word is a palindrome. So we'll just say answer, right, is equal to is palindrome, and then we're just going to pass in word to check. So this is going to return a true or false based on that. And then we can say if answer response is else response is not. Oops. Now there's a couple different ways we could do this, and I'm going to show you two once we're done with the whole thing. But then we can say, now we just want to print, we're going to have two different inputs. Palindrome. Then we're going to call dot format because we're going to bring that back into this, and we're going to pass in word, and we're going to pass in response. Response. There we go. All right, so let's go ahead and take this for a test drive. So we can comment out our unit test now because we're confident that this works. So let's go ahead and just do a triple quote there, and that will comment out that section of code. And we'll go ahead and run it, and we're going to say word to check. Well, right there, that's kind of ugly, so I'm going to want to fix that. But let's put in wow, and it said, oh, we got an issue. Word is not part of the program. So I screwed up something. Oh, word to check. Helps if you use the right variables, right? And while we're at it, let's go ahead and fix this. We're going to add a colon and a space. Let's run it again. All right, word to check. Now you can see that we've got the separation here. It makes it a little easier to read. Wow. It says, wow is a palindrome. Cool. All right, let's run it again. Word to check. Let's try with the capital letter. We know this works because we've tested it. So there you can see our response, and it's accurate. All right, a couple other minor things that we could change. We could say, we could get rid of one of these binary selections, and we could say response is equal to is not, right? And then if our response is a palindrome, then it will simply change it to is. So now we've got rid of one conditional. Another thing we can do is we can completely get rid of that right there, and we can say, well, I don't need that intermediary variable to store the response. I can just use the result to check to see if it is or not. So that cleans up the code a little bit right there, right? Now we're going to want to use this here because we're going to want to store that because we have to use it in multiple places. So this is legitimate. You want to use that as an intermediate variable, but you can trim other stuff in other places. Another thing we might want to do is just add a comment here. Check to see if word is a palindrome and change response accordingly. Now again, this is pretty self-explanatory what we're doing here. This code isn't hard to follow. It's only 3 lines. So this is probably overkill. However, it's good to get into the habit of putting comments in your code because you're going to be starting to write longer sections or longer sequences of code that it may not be quite apparent as to what you're doing. So you want to tell the user, whoever's looking at your code, what you're doing. In this case, I'm going to be the person looking at your code, so it can really help on the grading when I'm looking at your code. And if you screwed something up, if you have comments in there that tells me what you're trying to do, you're more likely to get additional points than if you don't comment it out and I have no idea what you're doing, right? So, and then we simply just output results, right? So that's easy enough. Whoops, output. So there you have it. There is our palindrome checker, complete with unit tests and just a couple different string methods that we've used in the lesson to kind of bring it home. Again, if you don't understand anything that I've done here, ask the questions. Now in the exercise, we used a for loop to traverse the string that we were processing. And we can also use while loops instead of a for loop. Here you can see that I've got my string. I've set a initial condition and I said while position is less than the length of fruit, go ahead and print out the letter of the fruit, and then I update my position to be 1 greater than the previous value. So you can see here how the for loop automatically does a lot of this for us, and so this gives us a little bit more code that we have to type in, but it can be done. So as an exercise, let's convert our palindrome checker to use a while loop instead of a for loop. Okay, so here I've pasted in our previous work so you can see everything's the same. And all we want to do is we just want to change this function right here to use a while loop as an exercise. So the first thing that we need to do is we need to set our starting condition. Since we're already using I instead of, in our for loop, we can just go ahead and initialize that here. So I is equal to 0. So then instead of for, we're going to be using while. And instead of in range, we have to say while I is less than the length of the word divided by 2, right? And you might be tempted to stop there, but don't. The other thing that we have to do is we have to make sure that we are incrementing our I. So I is equal to, we can just use plus equals 1. This is shorthand notation for adding 1 to whatever stored in I. It is the same thing as doing this, I plus 1. Okay? So we're just going to use the shorthand notation for that and say I is equal to I plus 1, so which is going to increment I, and it's the same thing. And how do we know? Well, remember, we wrote our unit test down here to test it. So we can uncomment those out, and we can simply say, you know what? I don't want to execute my main method, so I'm just going to comment that out, right? Well, we should comment this line out too, because otherwise we're going to get an error. All right, so now we can just say boop, and we've tested it, and it passes. So here we made structural changes to our code, but because we had unit tests written, we can be confident that it still works. All right, so there's the value of unit tests. That's how to change a for loop to a while loop. Python has some other really useful syntax that we can use, and that's the in and not in operators. And so we can find out if a thing is in something else, if it's in a collection, if we use the in operator. So here's some examples of that. Print P is in apple, print I is in apple, so on and so forth. And here's the result. Yes, P is in fact in apple. I is not in apple, so that's going to return false, right? AP is an apple. That's in true. PA, that's not true. So you can see how this is an operator, and it's going to return a Boolean response of either true or false. And of course, we can negate it by using the not in. So print x is not in apple is going to return true. So that's a really useful function. And the other important thing that you need to remember is that every string contains an empty string. All right, so you can see how this is going to be a feature or a bug depending on how you want to look at it later on. We talked about the accumulator pattern before, so now let's take a look at how we can use it with strings. And one of those things is we can use it to build bigger strings through concatenation, right? And so a use case for this is building error messages. We want to combine a couple different things together to produce an error message that the users will know and understand. So here's an example of that. Here is a function called remove vowels, and we pass in a string s, and here we have our vowels listed with both upper and lower case, so A, E, I, O, and U, right? No Y, sorry. And then so here we have a new string called s without vowels, and notice how we initialize it to an empty string. It has no letters in it whatsoever. So for each character in our original string, we're going to say, well, if each character is not in vowel, then we are going to add these two things together. So our string without vowels is going to be combined with string with vowels with each character. So it's just going to go through whatever string we pass in. It's going to say, hey, does this character exist in this string right here? And if not, go ahead and append it to the end of this string without vowels and then return the result. So here's what that looks like in code. So here you can see that we've imported our test class, and we've got our function here called remove vowels, and we have our list of vowels and our function as it was shown in the slides. And here you can see I don't run any main method. I just simply write some test cases to test that it works correctly. So here Corey should return cry, A, E, I, O, and U should return nothing for a null string, and then A, E, I, O, U, and sometimes Y should return this blah right there, right? So we go ahead and test it, and you can see that it passes. So that's just seeing what the code looks like and how to test it. Section 9.15 is an interesting section. And I'm going to admit, when I first started, I had no idea what else systems were. I had never heard of them. But it's really interesting if you are at all nerdy like me. So basically what a else system is, or a Lindenmayer system, is a mathematical description of a set of rules and a grammar to define the construction of a system. And you're like, that sounds really boring. And it requires a set of variables, constant, rules, and an axiom. And you're like, that isn't making it sound any better. The axiom is the starting condition or base case. Okay. Now, if any of you have already taken discrete mathematics, you'll know all about base cases and induction proofs. But we're not doing any proofs here, so you can relax. Right. So all of these things and go together with some rules that define how we translate these variables into subsequent patterns. And you can read more about it in the Wikipedia entry on else systems. And what you'll find there is that else systems are basically a system that's encoded into nature. If you look, you'll see that many things that we see in nature are built using processes that are very similar to else systems. So here's an example of some weeds that are grown using an else system. Now this is a computer generated model, but you can see how it mimics what happens in biology. And if we scroll down the page, you can see some different examples of how these else systems, how it works, right? Here's an example of algae and a fractal tree or a binary tree, right? And there's all kinds of different things that are both nature inspired and mathematical in nature. So like the Sierpinski triangle and all kinds of other issues. Like here's a fractal plant. So it looks really cool, and you can see how this system is being built. And we're going to do this in Python. So let's go ahead and take a look at it. But before I do, I kind of want to make it clear what's going on. So in an L system, we have a set of variables. We have a set of constants that may or may not exist. We have an axiom, which is our initial condition, right? It's our truth. And then we have a set of rules which describe how we translate our variables into something else. So you can see in the case of this algae, right, we have our starting condition, which is A, and A becomes AB, and B becomes A. So we are going to iterate a certain number of times starting with our axiom, right? This is our root. This is where we're growing from. So you can see here, we start off with A, and then following our rules, A becomes AB. So then at the next step, well, A becomes AB, so you can see A got replaced with AB, and B becomes A. Well, then you just keep following this over and over and over again. So A is going to become AB, right? And then B is going to become A, and then A is going to become AB. So you can see how this grows. And here is an example of you can see how it's growing based on using a tree. All right. So the cool thing about this is you could modify your variables and your constants in your rules to really create some really crazy stuff. So I just want to go over the terminology again before we start looking at the code, because it gets kind of involved. So here we are at the L system code, and you can see here that we are importing our lovely Turtle Graphics library, so you know we're going to be using that. And we've got a number of methods. We've got create L system, we've got process string, and we've got apply rules, and then we finally have draw L system, and then we have our main function. So what's going to happen is we're going to use the first couple rules or first couple functions to go ahead and process our L system. Then once we have a completed L system, we are going to use that as our what we're feeding into our drawing, and our lovely turtle is going to go ahead and process that and do a drawing of it. All right, so let's start at the top here, and I've kind of minimized everything so we don't get out of sorts with there too much stuff going on. So first we have create L system, and it processes the L system using a starting axiom with a number of iterations. So we're going to pass in how many times we want to do it, and we want to pass in what our starting axiom is, right? And it says right here, number of times to process rules, axiom is the starting condition, and it returns a processed string. All right, so if we go down here to our main method, you can see here that our instruction is we're going to call create system, and we're passing in 5, and we're passing in F as our starting axiom, right? So, and that's all we're doing here. We're just calling this one function, and we're going to store its result in the instruction variable. All right, so we pass in F as our starting string, our axiom, right? All right, so our starting string is equal to our axiom. So this is F. So we've just passed in F, and that's all it is. So now for I in the number of iterations, so we're going to loop through this for a certain number of times, we're going to process our string. Well, at this point, our starting string is just simply F, right? That's our axiom. And it is going to return the processing of it, and it's going to be stored in end string, and that end string is going to become our new starting string. So here, really, we could skip this, and we could just say, you know what? Our starting string is now our end string, right? So we could skip that line right there, but we'll leave it for now. And we want to return our end string. We want to return what the end result is going to be. So we're using the accumulator pattern to add things in. All right, so now we're jumping to process string. So that's a new function that we're going to be using. So we're passing in F because starting string right now is just simply F. All right, so let's go take a look at what process string does. So process string takes in a string, and it processes each character based on rules, and it returns the expanded result. So this is simply just saying for each character in the old string, we're going to create a new string that consists of the new string plus whatever rules we apply to that particular character. And then we're going to return the result. So this is kind of, you could say it's unnecessary, but we're going to leave it in here because it helps us separate the code out a little bit more. So all this is doing is it's going through, for each letter in the string, it's calling the apply rules function. So that brings us down to apply rules. And here we're passing in a single character to the apply rules. So here you can see that we have a new string, which is set to null. So you can see a lot of new string, new string, new string, right? And here you can see that we have a rule. So I'm going to go ahead and comment out this one and enable this one, right? So we can very easily change the rules. So here we have character is equal to f, which is our starting axiom, right? And our new character, our new string, our rule is, our only rule is that if our character is equal to f, then we're going to return f minus f plus plus f minus f in its stead, right? Otherwise, if a character is not equal to f, we're not going to apply any rules. We're just going to keep the character as is. And we're going to explain what f and minus and plus is when we look at the draw system, okay? So this is just defining a new, is substituting in what our rules are, all right? So once this is all done, it's going to return this process. So when we passed in f, we're going to go ahead and return this as a result, which is going to return it up here. Our new string was blank, so it's going to return it, which is going to come up to here and append it to the end. Once all of that is done, we're going to iterate over this a bunch of times. We're going to get back to here, and all those instructions are going to be stored. So let's go ahead and walk through this in the debugger so you can see what I'm talking about. All right. So we're just going to go ahead and put a breakpoint right here, and we're going to go ahead and run this in debug mode. So here I have another file which is just slightly modified, and you can see that I have given it a couple extra instructions. So now I've got F and G, which is just going to go, they're both going to go forward a distance. So whether it gets F or G, it doesn't matter, it's going to go forward. But up here you can see that I have a different grammar. Now I have two rules that are applied depending on whether it's an F or a G. So here I've got, if it's an F, go ahead and replace it with this, and if it's a G, go ahead and replace it with GG. And the rest of it is the same. So all I've modified was just the rule set, what happens, and the variables that are used in our instructions. Now I'm creating an else system with I'm going to go 6 iterations, and I'm starting with the following axiom. And so we're going to go ahead and run it and see what happens. So you can see by just modifying those rules, you get this crazy looking else system that comes out of it. What happens if I make it 7 iterations? Well, let's close this. Let's go ahead and minimize this. We can delete it actually. And here, that's the old one. Let's go ahead and delete that. So all I want to do is now I'm just going to say, you know what, I want you to run for 7 iterations, and we're going to see how it changes. So it made an extra level. So you can see how it's just going to keep growing and growing and growing. Now, I haven't bothered to center the canvas at all or anything like that, so we should probably do that. And you can experiment around with it and say, well, I need to change how my drawing is set up. But I'm not going to waste time doing that right now. So here, if we were to only specify, say, 3 levels and we ran it, you can see that it just makes a little triangle, right? If we specify 4 and run it, you can see that it executes it one more time. So it's recursively drawing it bigger and bigger and bigger. So this is just, it's a lot of fun to play around with to see what types of creations you could make. It's also fun to look at other else systems as they're described in different places. You can go on the internet and search for these rule sets, and you can modify your turtle to draw those rule sets and to get the same results than what you can see online. And there's some really cool stuff out there. So I highly recommend you do some investigation and look up more on else systems. All right, so I'm hitting debug mode. I'm going to run and debug, and we're going to debug a Python file. So you can see it stopped here. So we're going to step into this. We don't want to step over it because then we won't get to see what happens. So we actually want to step into this. So we're going to go ahead and click F11, and here you can see our starting axiom is F. We've passed in F as our value, and our number of iterations is 5. You can see because that's what we called the function with and passed in as parameters, as arguments. So we passed in 5 in F, and so you can see we're right here. So if I go ahead and step over, all right, so now you can see that starting string is equal to F. We're going to go ahead and step over. End string is a null string. And so now for I in range of number of iterations, we're going to execute some things, right? So we're going to step over that, and we can see that I is equal to 0, and we're going to go ahead and step into this. Whoops, I stepped over it. I didn't mean to do that. We'll catch it on the next run. So here you can see our end string, after we got done processing it, is F minus F plus plus F minus F, which is exactly what this rule was down here, that if our character was F, go ahead and replace it with that, right? So now we're back up to here where our end string is equal to this, and we're going to go ahead and step into, and now our start string is F minus F plus plus F minus F. All right, we're going to go ahead and step into that, right? We're now on I equals 1, so we're just counting. We're not actually using this as any type of indexing variable. And so now we're going to enter into, we're going to enter into process string, and our start string, if you look at it, is F minus F plus plus F minus F. And again, I know this makes no sense right now as to what this means, and we'll see what it means when we get into the drawing part. All right, so we're going to enter into this, and so now we're going to process the string, and so our new string is equal to an empty quote, and for each character in old string, which is the string we pass in, which is this sequence right here, we're going to go ahead and apply the rules. So we're going to step into that, right? So you can see our new string is blank. Let's go ahead and step into that. We create a new string, and we're going to step into that. If our character is F, we're going to return that, right? Which it is. So we return that new string. So now we're going to append that to this string, and so now you see our new string is F. But we're still processing the next letter in old string, which is going to be this second character right here. So this is where we're at. So we're going to go into process rules. You can see character is the hyphen, just like I said. And we're jumping down to apply rules. And we're going to say if character is equal to F, do this thing. Well, it's not. So we're just going to return the letter that it was. So you can see new string is now the hyphen. And we're going to come back here. And now we're going to add our hyphen to the end of it. So we've appended the hyphen to our F minus F plus plus F minus F, right? And so we're going to keep doing this process of we're checking each letter. So here, our next letter is an F. So now we're going to substitute this in, right? So our new string is that. So now we are going to append this whole sequence right here, what was returned, to the end of our new string. And so here, now you're going to see it grow. And so we're going to continue doing this for each letter, each character in our old string. So next character is going to be plus, and then we're going to have another plus, then we're going to add another whole sequence, and then we're going to add a dash, and then we're going to add a whole another sequence, right? So if I just go ahead and just step over that, you can see that that's exactly what's going to happen. And you can see our new string grows in length. So now we've processed every character in the old string, and you can see that our new string is this long sequence of characters. Okay? So now that we're done processing that, we're going to return that value right here to the calling function. So let's go ahead and step into that. So that was that whole part right here. So now our end string is the result of that. And we're going to do it again for a number of iterations for however many times we said. So we said I is equal to 1, and we're doing 5 iterations. So now we're just going to step over that, because now it's going to do the whole thing over again. And we're going to do it over again and over again until I is equal to 5. So here you can see we have completed this whole process, right? So if I were to stop this, if I were to set a new debug point here and we were to redo it, let's go ahead and run and debug it. And we stop a breakpoint there and go ahead and look at the output. Oops, I forgot to uncomment out my print. So let's go ahead and do that again. We'll stop it. Oops, I could have just reran it. This is the result after 5 iterations. Whoops, let's make it even bigger, right? So after just 5 iterations of executing this, you can see how much our sequence has grown from just one lonely F, following one rule of replacing F with F minus F plus plus F minus F. And you're like, all right, cool, you did a bunch of letter substitutions. Why is this neat? So that is going to be a rule set for how we draw something. So here you can see that we are going ahead and creating our turtle, right? So I'm going to go ahead and comment this out. Now that we've got our instructions, right, we're going to go ahead and create our turtle. So let's add some comments in here. Set up turtle environment. Okay. So here we're going to do all that. We set our world coordinates, we set our tracer program, and then we're setting our speed. Now we're going to call the draw our L system, right? Oops. And this is where the magic happens. So let's go ahead and run this and I will show you the results. So I'm going to click resume. Oops, I'm going to clear out my point, click resume. And so now it is drawing the L system. So let me go ahead and open up what that it looks like. So it's done. So now you can see, and our canvas is kind of squished a little bit, but here you can see that it created this triangle pattern of, looks like half stars. So that's pretty cool. So the string class has its own find function, but we're going to write our own find function to show you how you can use a while loop to process through strings. So here we have defined find. We're passing in a string and a character, and we're going to look to see if we have the character occurs in a string. We're going to return -1 if it doesn't occur. So here we have ix representing just the index, and then we are setting found equal to false. And while our index is less than the length of the string and not found, we are going to look through the string to see if the character exists. So we're going to look at each position in the string and see if the character is there, and if it's not found, it's equal to true. Otherwise, we're going to increment ix, and again, this could be plus equals 1 just as well. And we're going to continue searching. Once we get through the entire thing, if it is found, it's going to return ix. Otherwise, it's going to return -1. Now, this part right here is important because once we find the character, we want to cease processing. So that's why we check to make sure that it's not found. If we omitted this part right here, if we just said, you know what, we don't need this, it's unnecessary, we're gonna nix it, well then it would process the whole thing and it would only store the location of the last found item. Actually, it would just return the last index. Even if it was found, it would just keep going and process, so we would get the length of the string -1. So we need to make sure that we are stopping when we actually find the item, so that way we return the current index. So also note how this is a Boolean expression here. So this and not this is going to combine to have some equivalent expression of true or false. So this is just an example of how to use a while loop and to write your own find function. Now, the string class has its own find function, and so you don't have to write your own. It was just an exercise. Finally, let's talk about optional parameters. And I've mentioned this before, but let's take a little bit closer look at it. We can define optional parameters by giving them default values. And the variables that have optional values, they have to come after ones that do not have optional values, right? It has to be at the end of the list. So here's an example of a new find method where we're passing in a string and a character in a optional starting location within the string. So you can see here that we are giving it the optional value, right? So we're saying if the user of this method or function doesn't give us a start value, we're going to start at 0. So you can't have this at the start, because then you won't know if it's optional or not, and so it screws up everything. So every optional parameter has to be at the end of your parameter list. And then as an example of calling it, here we could just call find3 banana a starting at position 2, which would be this n right here, so it would return 4. Okay, that brings us to the end of strings. Now, I did not cover everything that there is to do and know about strings. This is an intro to Python class. This is just enough to get you started and to let you realize that there's a lot of things that you can do with strings and a lot of way to manipulate strings, and we barely scratched the surface of it. So go out, do some more research, look up how to do things within Python, flex those, researching skills of yours, and learn all there is that you can with strings, because strings are going to be used all the time in any programming that you're going to do, whether it's in this language or another language. So it's really important to have a good mastery of it and a good foundation of all the string methods. I will say that you need to make sure that you know how to use the string methods that were presented in the textbook and in this video, because that is going to be definitely testable material. So make sure that you know how to use the functions that were presented here. Do you have to be a master of L systems? No, you do not. That's more of a fun exercise in showing you how you can use a string as an input to some other completely non-string related thing, like making a drawing, right? So just pay attention to the functions that were used and focus more on that, and just practice with working with strings. And as always, if you have any questions, make sure you ask. Thanks.